Hiya! On today's episode, we will tackle a past step question once again. And if you have noticed a pattern, I love integration. So this is yet another fancy integration question. If you can handle this, you can handle anything that the IB is going to throw at you. So let's start with part one. We want to show by substitution that this identity is true. Now, this is a rather standard question that you should all know how to do by now if you're aiming for a 7 at HL. So, if u is equal to 1 minus x, du is equal to minus dx, we'll also change the bounds. X goes from 0 to 1, u therefore it goes from 1 to 0. The integral now becomes the integral from 1 to 0, 1 minus u to the n minus 1, times u to the n times negative du. You can take a negative out and reverse the order of integration. And because everything is in terms of u, we can just replace it with x, because it is the same function that is being integrated. And you're good to go. Second part, deduce that this is true. This is yet another standard result. So let's start with the left-hand side. We want to get I of n minus 1 on the right-hand side. This is effectively the integral from 0 to 1, x to the n minus 1, 1 minus x to the n minus 1. In other words, In when replacing n with n minus 1. I'm going to split it up into two parts. Keeping one part as is, and use the result that we have just proven for the second part. Since we're integrating over the same bounds, we can then combine the integrals. Take out the common factor, and this simplifies to 1. So that is the second part of the question done. Third part of the question. We want to show that I of n is equal to this expression over here. Now, notice that I of n, we have powers n and n. On the right hand side, we have powers n minus 1 and n plus 1. So if that means that you have to differentiate one part and integrate another part. This means that you will be using integration by parts. On the IB exam, they will give you a bit more hint. But you should be able to draw that connection yourself. Which one to differentiate, which one to integrate? X to the n becomes x to the n minus 1. So that means that you'll be differentiating x to the n, and therefore you'll be integrating the other part. differentiating x to the n with respect to x, integrating 1 minus x to the n with respect to x. Using integration by parts, we can see that the right hand side is coming along. Let's plug in the upper and lower bounds here first. Convenient. Lower bound. Convenient. This is O0. Minus, minus. And here we go. So we have just obtained this integral over here. For the last part of the question, we're then asked to derive this result. So, is there a way for us to do that? Look at what we have done so far. We can show that each integral up here is equal to a half of I n minus 1. So, what we can do is splitting this n plus 1 up so that we have 1 minus x to the n times 1 minus x. Because then if you combine the first two terms together, you will get a half I of n minus 1. And for the second half, you would also get the same thing. So let's actually do that. Carry on with this guy. Integral from 0 to 1. And by n plus 1, x to the n plus 1. 1 minus x to the n times 1 minus x dx. Now we are going to expand this. I'm going to take this out. We have the integral of x to the n minus 1, 1 minus x to the n. And the integral of x to the n minus 1 times x times 1 minus x to the n. This part, as we've shown earlier, is a half of I n minus 1. Second part, I'm going to make a minus here. That will get us to x to the n, 1 minus x to the n. This is your in. So, therefore, in is equal to n divided by n plus 1, a half I of n minus 1 minus in. We want to express in terms of in plus 1. It is simply a game of rearrangement. And there lies our final result. This is the end of the first part of the question. In the next video, we'll go over the second and third part, with an emphasis on choosing the right method for each part.